Let's talk about polynomial regression for the second test review of the second 6 weeks. We have this data here, and it says let me move this out of the way so I can see what it says. The following data represents the weekly cost in thousands of dollars of printing textbooks and the number of textbooks X in thousands of units of text printed. Okay, so this part right here, thousands of units, that's going to be very important when we're answering these questions coming up. So if I have my X values here, number of textbooks, 5, 10, 13, and so forth, this is not 5, this is 5,000. Okay, and the cost wouldn't be just 100, but this would also be in thousands of dollars, $128.1 thousand, and so forth and so on. So the first thing that we need to do is we need to enter this information, these X and Y values, in our calculator. The first of all, before I even start talking about this calculator, what we're about to do is almost exactly the same as what we were doing with linear regression. Okay? So we want to always clear our calculator. Second plus 712. Go to Stat, hit Enter on Edit, and it'll bring up our L1, L2 lists. Our X values go in L1. Our Y values go in L2. So let's enter this in. And after you get it entered in, especially with this many numbers, you want to just go back and make sure you didn't enter anything incorrectly. It's really easy to do. Okay, so we got our data in the calculator. Before I do anything else, I want to adjust my window. Go to the window, and we have to make, this is a part where a lot of people are confused, and I'm really not sure why. Pay close attention. These are my X values. These are my Y values. For my X values, I have to make my X minimum a little bit smaller than my smallest x. So my smallest x is 0. Maybe I make my x minimum -10. I'll just leave it that way. Maybe you would make it -5. Maybe somebody would make it -15. Those numbers can be different from person to person. What we're trying to do is frame this data in. Okay? My x maximum needs to be a little bit bigger than my biggest x. So maybe I'll make it 35. Because my biggest x is 27. So I'll make it 35. We're going to make our scales 0, just as we did before with linear regression. My smallest y is 100. Maybe I make it, I don't know, 75. Just giving myself some cushion. My largest y is 221.8. Maybe I make my y maximum 250. Just giving myself a cushion. Now I have my window set. If I go to y equals, I need to go to y equals, scroll up to the top where it says plot 1, hit enter, and it'll highlight plot 1 turning on my scatter plot. So now that when I graph it, I can see my data. If you didn't adjust your window, you're not going to see this data. You have to adjust your window. You have to frame it in so that you can see it. Okay? Now we can move on. A says write the cubic regression, so I have to go back to my calculator, and it's telling me cubic regression. It's a polynomial. A cubic function is a polynomial, but it's telling me what type of regression I have. So I go to stat, scroll right to calc, where before we would choose number 4 for linear regression, we're going to choose number 6 for cubic regression and hit enter. And I have my equation here. Now, sometimes when we try to, this is my equation. If I go to y equals, the calculator has the capabilities of pasting that in for me. Sometimes it works and sometimes it doesn't. Typically with a linear function it works. Sometimes with a different type of function such as a polynomial it doesn't work. But sometimes it does, and I'm really not sure why. There's probably a simple fix that I just don't know. But the way you're supposed to try to do it is go to vars. Once you're in y equals first, then go to vars. Number 5 for statistics. Scroll right to equation and hit enter. And this one's not going to work because, see, you have this box here. And so something's not going to work, but I'll try to graph anyway. We'll see what happens. See, it didn't work. So this is what we want to do to fix that. Some do work, and it's okay if it works, then roll on. Mine didn't work. If it doesn't work, what you want to do is you want to find your equation, stat, scroll right to calc, number 6, hit enter, and round this to the nearest 3 decimal places. So you would have y equals 0.015 x cubed minus 0.595 x squared plus 9.150 x plus 98.433. And once you have that, I can't write it on this paper. If I write right here on my screen, as soon as I try to put it in the calculator, it'll erase anyway. So you can do that on your own. Just round the nearest 3 decimal places and then just manually type it in. And that little caret key there will give you to the 3rd power, this little upwards facing arrow looking thing is called a caret key. That'll allow you to do x to the third. Then minus 0.595 x squared, and then plus 9.150, or just 15 x plus 98.433. And you do want to stick to the rule when you are rounding to 3 decimal places. You want to stick to 3 decimal places. Now graph it, and we'll see that cubic function going almost right through every point there. So that looks like it's a pretty good fit. Okay, so now you would record right here what your cubic regression was. If I'm going to draw the scatter plot, the first thing I need to do is label my axes, the y-axis and the x-axis. The x-axis is the number of books. And the y-axis is the price or cost of books. And I can sketch this just kind of like what I see here. I'm just sketching it. And then if I wanted to take a different color and draw the actual cubic regression, it would look something like that. Just a basic sketch there. My sketch isn't perfect. Yours doesn't have to be perfect, but it has to be. I have to be able to tell that it resembles what the actual graph is. Okay. Now when I scroll down here, everything that I just wrote down is going to disappear. Now let's answer some questions. Graph the regression equation with a scatter plot. Did that. Predict the cost of printing 22,000 texts per week. Okay. If I go to my table, I want to know what y is when x is 22,000. And some of you are thinking, that's a long way. Well, not if we remember that we are in thousands of units. So 22 here is 22,000. And so the answer would be 171.47 thousand dollars. Now some of you may be thinking, no, it's 176. Well, the difference is, remember, I rounded to 3 decimal places. Some of you may not have had to if your calculator was able to paste it in Y1. When I grade these problems on the test, I allow for a little bit of a difference. Not much, but a little bit. And here's something else. If the directions say to round to the nearest thousandth place or 3 decimals, and you give me a whole number answer, I might count it wrong. So make sure you're rounding. E says, if $210,000 was spent on printing textbooks 1 week, how many textbooks were printed? What this is asking is, when y is 210, what's x? Well, I can scroll down here in my table and see if I get lucky if 210 is on there, but it's not. And so what I have to do is I go to y equals again and go to y2. When I'm looking for x but I'm given a y, and that's what's happening here, I'm given y, which is the cost, and I'm looking for x. This is where I typically have to go to y2 and put that y value in. Do not put 210,000 put 210 because we're in thousands of units. And when I hit graph, here's my horizontal line, y equals 210, and it's going to intersect right here. I want to know the x value when it intersects, because the x value is the number of books when y is $210,000. So I do second, trace, 5 for intersection. Take my cursor as close as I can get it to the point of intersection of the two functions. Once I get it as close as I can, hit enter 3 times. And the answer is, when we spend $210,000, we've printed 27.302 textbooks. Thousands, in the thousands. This is again in thousands. And that's how you do the first regression problem. Now, I'm not going to work the other regression problem on the podcast. They all work the same. You have to be able to, first you have to put your data in L1, L2. Then you have to frame your window. Set your window to reflect the data you put in. And then go through every step just like we did, and you can work any regression problem. I better